Hello everyone and welcome back to our YouTube channel Sharang and Sharwari. Today, I would like to talk about my favorite topic, which is the quantum mechanics and the double slit experiment. But before that, I would like to extend a sincere thank you to all of our subscribers and viewers. Thank you for all your love, thank you for all your comments, and thank you so very much for all the subscribers and the positive and negative feedback that you guys give us. Without further ado and getting straight to the point, like today we are going to talk about the double slit experiment, which is one of the most important experiments in quantum mechanics and how it began. Okay, so Sharwari, double slit experiment. Have you ever heard these words in your entire life?
I'll be honest to everyone, I haven't heard the word or phrase quantum mechanics as well. So I think
Okay.
we know where we are going to start,
Okay.
basically.
Okay. So quantum mechanics is essentially a relatively new field in physics. I mean, it is the newest field of physics. Is pretty old, as in new fields have not come up in it
Emerged, yeah.
that much. So it essentially deals with the behavior of particles which are very, very small. That is at the quantum level,
Oh,
right?
okay.
So it doesn't deal with massive molecules even. If we are talking about the scale of particles of individual electrons, maybe in some cases neutrons or atoms, but like very, very small particles, such as quarks, for example. Quarks basically, so I think everyone knows that matter is made up of atoms, which are called atom because it's considered indivisible. It's not so. Atoms are made up of electrons, neutrons, and protons, and they are further made up of quarks. So the most basic unit of matter that we currently know. So the double slit experiment begins with so to know and understand the double slit experiment, you also need to understand something known as interference.
Firstly, I want to ask you a question.
Yes.
So, why did you feel like enlightening the audience with this particular concept?
I'm a huge nerd. That's no, the
I
thing is,
know that you
yeah,
guys might be.
like it's a very, very amazing concept, and it leads to some insane conclusions. And quantum mechanics is something that I find truly fascinating. I don't understand it that much because I'm not a physicist, so I don't have the mathematical understanding of the formulas. But definitely, I've heard a lot of podcasts by people such as Dr. Brian Greene,
Right.
Dr. Brian Koch. And they have enlightened me on these topics. They have added to my knowledge, and whatever the way they explained it to me blew my mind pretty much. And they raise important questions about the nature of consciousness, and they make raise important questions about reality itself, and that's why I care about this topic so much. So, do you know what an interference pattern is?
I'm afraid that every answer you'll get in this video would be I don't know.
Okay.
Because I mean, I think our audience knows where we stand in terms of studying, and
Yes.
I, to be honest, have not done a lot.
Okay.
So whereas he has. So I think you can literally
Okay.
in that.
So when the thing is waves, right? What is a wave? It's essentially it's a pressure differential like that propagates in space time, right? So let's say like I'm talking to you. What is that? So the air is exploding out of my lungs, right? And that is causing like pockets of air to compress, pockets of air to relax, pockets of air to compress, pockets of air to relax.
So
And
sound waves.
yes, but that energy is spread in a in a sphere all around me, so it dissipates with time. So light is also an electromagnetic wave. That is, it consists of an electric field which generates a magnetic field, which also generates an electric field. So it's an electrical and magnetic field which generate each other in
So
phase.
it's like a interconnected process, basically.
Yeah, so
In a way,
there's an
yeah.
electric field which generates a magnetic field which generates an electric field ad infinitum. And the direction of propagation of light is perpendicular to all these directions.
Oh.
So every wave has a crest or a high point and a trough, a low point. So imagine that two waves, right? They interact in such a way that the crest of one interacts with the trough or that is the high point of one wave interacts with the low point of another wave. And imagine that the amplitude, right? That is the height or depth of the wave from baseline is the same. In this case, the two waves will cancel each other out and you'll get nothing. You'll get darkness.
Oh, okay.
Right.
Right.
So an interference pattern is basically when two waves interact, and in those areas where, like, let's say you have light from a laser, right, which is, and you split that into two beams, and then you make those two waves of wavelengths of light interact with each other. They will produce an interference pattern. So let's say there's a source of light, and next or in front of the source of light there's a screen with two small slits, and then there's a detector behind those slits.
Okay.
What will happen is that light from this laser will pass through those slits, then those waves will interact with each other to produce an interference pattern on the screen behind. You understand what I'm saying?
So far, yeah.
Okay, perfect. This is not the weird part, right? Because this is so there was a lot of debate: is light a wave? Is light a particle? The answer was it's both. It's essentially quanta, right? So the way to understand light is in terms of photons or quantum of radiation, which propagates in space-time as a wave. I know it seems like I'm putting out jargon to confuse people, but that's the way it is. So now we come to particles such as electrons and photons, right?
Okay, that's one term I actually know
Yes.
because I went to school. So,
So an electron is basically a particle which like orbits, quote unquote, an atom, right? So
oh
it's
yeah,
yeah,
exactly. I
it is
remember.
considered to have a negative charge. Now, why am I saying that electron is considered a particle? Because of the what I'm about to say in the double slit experiment. So imagine this, right? Imagine there's a tube which is emitting just one electron at a time, and imagine it is going through to a screen which has two slits, right? And then there's a detector behind, right? So if you, like in our model, electrons are particles, what would you expect to happen? Like the electrons will, and let's say there are slits A and B, right? Imagine the electron is like a tennis ball. What do you think will happen?
It will bounce back.
No, no.
Then
Imagine it's small enough to pass through one of those slits.
it will pass through.
Exactly,
Yeah.
but it will pass through either. So let's say there are two slits, either A or B. It will pass through either slit A or slit B,
Okay.
and then
Yeah.
hit the detector behind or the
On the
wall
other
behind,
side.
right? Now
Exactly.
let's say you do this with electrons. That does not happen. This does not happen at all. So what actually happens when you try to do this process with electrons is you get the same interference pattern that you got with light waves.
Oh.
Yeah.
Oh.
So
Okay.
which and this when this experiment was first done, it caused us to question the nature of matter itself, because matter is supposed to be made up of these particles, right? Neutrons, like neutrons and protons, which are in the nucleus of an atom, are obviously particles, and the
Right.
electrons which orbit them were also considered to be
Right.
particles. And in many cases, they behave as particles, right? Electricity is a flow of electrons. So why are they not? So they are particles essentially, right? Turns out they have the properties of waves. So there's a principle called the de Broglie wave principle, which means that all objects can sometimes have wave-like properties, right? So basically, the way to understand electrons, as was proposed by Niels Bohr, is in terms of a
Right.
probabilistic wave.
Okay.
Right.
Okay. Right.
So then like this is not the experiment which causes your mind to be blown, right? The part of the experiment which causes your mind to be blown is, okay, so now you know that when you have a device which is emitting a single electron at a time, it's passing through either slit A or B, and but on the other hand, when you look at the detector, it's actually producing an interference pattern, which should not be possible, right? Because if there's literally just one electron going at a time, how is it even producing an interference pattern? Like, who is it interacting with?
Exactly.
So if you think about an electron as a probabilistic wave function, then that wave function is literally interacting with itself to produce an interference pattern.
Oh.
Yeah.
Oh.
Now, the second part of the experiment is where they put a detector, right? So imagine you still think of electrons as particles, right?
Yeah.
And you're trying to find out, hey, did this electron actually travel through slit A or slit B? Which slit did this electron actually travel through before hitting the detector? So before hitting the main detector on the wall,
Correct.
right? So what you do is you put another detector near slits A and slit B, so that you can find out, did this electron go through slit A or slit B? Guess what happens to the interference pattern?
What?
It completely disappears. So the
Oh.
moment you set up a detector, this interference pattern that you're observing completely disappears. And now we have an experiment where electron is either going through slit A or slit B, and you just get like a pattern of two electrons hitting the wall on the other side. So this interference pattern which these electrons were producing goes away, and then electrons are behaving as waves or probabilistic waves only until only as long as a detector is not there. And the moment we put a detector to try to see where those electrons are and how they're behaving, they act as discrete particles. This breaks reality. Now, I just want to be like, this has led a lot of scientists to
Exactly.
extrapolate a lot,
Correct.
and
Yeah.
sometimes it goes into territory which is not, let's say, on firm scientific ground, right? But
What do
this,
you mean by that?
so in the sense that some people say that it's the nature of consciousness, like imagine that, like, so this is the famous correspondence between uh, Erwin Schrödinger and Albert Einstein,
Oh.
right? When they were writing letters to each other, and Erwin Schrödinger was explaining this quantum effect, and
Yeah.
he was explaining this quantum weirdness. What Einstein said, I would like to believe that the moon is there even when I'm not looking at it. But what it's literally saying, right, is that if you detect something, you will find it.
Right.
But if you don't detect it, it just is not even there.
Oh.
Which is not the way scientists are trained to think, right? We are trained to think about an objective universe which does not care about whether or not an observer is there, right? So a lot of
Correct.
science is actually about removing the observer effect to judge things in an impartial, like sort of way, right? So this completely shatters that, because somehow the detector is interfering with the wave function to resolve it.
Exactly. Yeah.
But this also raises questions that, oh, so basically, as long as you're not seeing the interference pattern, it's not there. But the moment you try to find it, it just disappears, which is crazy, and this should not happen. And honestly, this experiment was done like 50, 60 years back.
Okay.
And they have done multiple variations on it to somehow try to find which slit the electrons went through, whilst not destroying whilst keeping the interference pattern intact, but it never happens. The moment there's a detector, and the moment you have this information, the interference pattern just disappears.
So is like research still going on this topic?
I mean, yeah, but it's been going on for 50 years by the brightest minds of the country, so you can imagine. So the thing is, what do we do from here, and where does this go? Because, like, I've heard a lot of crazy theories about it. One is that the role consciousness plays. So some physicists and some people think that, oh, your consciousness sort of causes the particle to manifest itself in that particular position.
Oh, wow.
Yeah, which is not backed up by
That's
science.
some crazy thinking.
Yes, and
Yeah.
this what I just said is not backed up by science. There's no proof. Another hypothesis which was actually propounded by, I believe, Dr. Brian Greene, Dr. Sean, and like a lot of physicists tend to believe in this hypothesis. It is the multiverse hypothesis.
Oh,
So
right. We have heard of that one.
yeah, multiverse, Marvel has made it famous. So basically, it's like, imagine a decision tree, right? Like, I'm on the road and I decide to go either right or either left. So multiverse theory proposes that there's a single point of reality, and then, like,
Yeah.
so the moment I make a decision to go either left or right, two universes are created, one in which I went right and one in which I went left.
So are you saying that these particles go to another universe together? Wow.
So it's like, what they're saying is that the moment you put a detector, you create two separate universes, one in which the electron passed through slit A and another in which the electron passed through slit B.
That is some content, people.
That is some content. It may seem, that's why quantum mechanics is so weird, because this seems like the kind of thing that a spiritual monk might say, or someone high on marijuana might say, but this is the scientific consensus. Not about the consciousness, but this theory of the multiverse is like a respected theory. We don't have proof for it, right? So guys, I think that's the end of this.
So, of course, like for me, listening to this was very like I did not understand the beginning, but later I slowly got catching up. So you guys can let us know if you like such crazy topics that we explore. This was something different that we did. So you'd really love to hear what is your opinion on that. Also, we see that you guys are liking our content, you're also subscribing, and our subscribers are going up day by day. So thank you so much for all the love and support. We love making content for you.
Yes.
And I hope to see you guys soon in the next video. And of course, if you have any video suggestions, you want us to try something, please write it in the comment section. We're waiting for it.
Yes. Also, people who are physicists, in case they're reading it, quantum mechanicists. I'm not sure how to call you. I guess I could
Yeah.
call you guys quantum physicists, or anyone who has an understanding of these, a mathematical understanding. If I made any errors, please reach out to me in the
Yes,
comments.
yes.
I'll be happy to correct myself. We love you all, and like, share, and subscribe, guys.
See you guys. Bye.